get started, are there any questions over the homework 2.1? Questions over the homework assignment? Okay. Again, today we are still focused on parabolas. This whole chapter will be over parabolas. And what we're looking at today are some of the key parts of a parabola, some of the properties of it. And when we're given vertex form is our a times x minus h squared plus k, we can get two main pieces straight from the equation. One of them is the vertex, and the other is the axis of symmetry. So the vertex, we talked about it a little bit yesterday. It is the point h comma k. H comes from inside the parentheses, and our k is what's added on to the end. Let's keep our head up. And the axis of symmetry is a line that's going to cut the graph in half. So every point to the left and right of this line will be equidistant from it. So everything's going to be mirrored across this line. So especially when we're trying to graph, it is helpful to have both of these pieces here, because the vertex gives us the highest or lowest point, and the axis of symmetry will always cut through that point. We'll go through that point, and it'll mirror across it. Now, part of the reason this is helpful is because if we are going to graph, or you had to graph these here, a parabola, you need 5 points. One of the points would be the vertex, and then you need 2 points to the left and 2 points to the right of that vertex. So, when we look at this here, -2 times x plus 3 squared plus 4, the main two things we're going to do is find the vertex and the axis of symmetry. I'm going to graph it. We will graph this, but I'm not going to put a big emphasis on graphing these. So let's compare this to the general form. So the general form in vertex form is a times x minus h squared plus k. So the three values that we have are a, h, and k. A for us here is -2. Our number value of h is 3. Now, would the 3 be positive or negative? Negative, because we have x plus 3. To match up to the general form, we're really looking at x minus -3. That's the only way we can get it to be plus. So h is -3, and k is 4. Two pieces of information we need to find are the vertex and the axis of symmetry. Vertex in the general form is the point h comma k. So the vertex for us is going to be what? -3, 4. We replace h and k with its values. So the vertex for this equation here is the point -3, 4. Now the axis of symmetry. Is given to us by the equation x is equal to h. So the value of h in this case here is -3. So the axis of symmetry is x is equal to -3. So we found the vertex and the axis of symmetry. Now, if we wanted to graph this, we would first plot the vertex, or -3, 4. We would plot that point. And we would use it and the axis of symmetry, which is going to be the line right here that goes through that point straight up and down. I don't need another one of those. And the reason these two things are helpful is because every point to the left and right of that line is going to be equidistant across. So, you don't have to write this next part. I'm going to erase this here. Take 2. Because if we're graphing a quadratic equation, we need 5 points. And the middle point is going to be the vertex. So we said the vertex is -3, 4. So to get our other 2 points, we would go 2 points to the left and 2 points to the right. And we would plug it in. So for -4, we would take the equation, -2 times -4 plus 3 squared plus 4. So we plug -4 in for x, and we simplify. So we can say -2 parentheses -4 plus 3 squared plus 4. So we would just plug this into the calculator, let the calculator simplify it for us to find our answer. And we see that the y value when x is -4 is 2. So our next point would be -4, 2. I'm going to do the same thing, but this time I'm going to plug -2 in for x. Again, we can say -2 times -2 plus 3 squared plus 4. And we get 2. Because again, we said the axis of symmetry points are mirrored across this line. So -2, 2. Because our point, 1 unit to the left of the axis of symmetry, should also be the same point or a similar point to the right. Because we went 1 to the left and we were at 2, which means the point 1 to the right should also be at the y value of 2. We can do this with -5. We can say -2 times -5 plus 3 squared plus 4. And we can simplify this to see what we get. -2 times -5 plus 3 squared plus 2 is -6. So our point is -5, -6. What do we think the value of -1 is going to be? What do you think the y value of -1 should be? -6, yes. Because if we plug -1 in for x, we should still get a y value of -6. Because this is 2 units over, it should also be 2 units over. Everything is mirrored across this line. And this is helpful, especially when graphing, because we said we had to have 5 points. But if I know the vertex and the axis of symmetry, I don't need to find 5 points. I only need to find the vertex and 2 other points. Because if I have those 2 points to the left or to the right, I know that the other 2 are going to be in a similar location. Because if I have the vertex and these 2 points, These other 2 points are going to have to mirror across that line. So knowing the axis of symmetry and how this works lets me still find 5 points, but I only actually have to find 3. Does this make sense? Or, especially, and again, the reason I'm not focused too much on graphing, because we will do this, is the graphing calculator. If we hit that y equals, it lets us graph. And in this first spot here, we can type this function in, -2, parentheses, x plus 3 squared plus 4. That is the graph we got, yes? And we can find and look at this here and see, is the point -3, 4 on this graph? So as we see here, -3, 4, scroll up, is this point here. It is on the graph, yes? And we know that it is the vertex because as we look to the left and right, the y values do mirror each other. If we go 1 to the left and right, the y values are both 2. If we go 2, it's still -4. It is mirrored across this here. We have this symmetry. But the main thing I'm looking for you to find is the vertex and the axis of symmetry on these here. So if we look at this next one, this one here, f of x equals 0.5 times x plus 4 squared minus 2. Again, the general form, a times x minus h squared plus k. So we want to find AH or identify what A, H, and K are. So A in our case is going to be what? 0.5 or 0.5. Our value of H is 4, but it would be negative. Because the only way we can go from x minus h to x plus 4 is if the value of h is negative. And our value of k is -2. Now the 2 pieces of information we need are the vertex and the axis of symmetry. 2 things that we want to find, vertex and axis of symmetry. Vertex, general point is h comma k. So, and the axis of symmetry is the point x is equal to h. So what's our vertex point going to be? Vertex is -4, -2, h comma k, so -4, -2. Once we find h and k, we put it in their spots, yes? Axis of symmetry, x equals h, and our value of h is -4. Questions on this here? Because if we really want to look at the graph, again, we can graph it. But as we're talking about this here, we know that the vertex is this point, -4, 2. It's axis of symmetry. So even if I'm not given a graph, 1, 2, 3, 4, I know that this here would be the vertex. We know that there's a line. It's going to cut through it, that everything's going to be mirrored across it. So it should look like a mirror image. The 0.5 that we would say is a vertical shrink. Now, because it's not negative, if that value of A is positive, it opens up. If it's negative, it opens down, which means that our graph, if I didn't even calculate any points, it should look something like this here. It might be wider, it might be narrower, but we know it's going to open up. So just from this understanding, I know we should have at least 2 solutions. the points where they cross the x-axis, it does give us an understanding, an idea of what the graph should look like. If we want it more precise, we can either calculate it or tell the graphing calculator to tell us what it is. Let's look at this one here. F of x equals negative 3 times x plus 1 squared. So our value of h and k. What's the value of a? A is negative 3. H, it is 1, but it would be negative because we have x plus 1 is going to have to come out as negative 1. And what's the value of k? 0. There is no value attached to k in its place up here. So the value is 0. Vertex. So vertex is hk, so h would be negative 1 and k would be 0. Axis of symmetry. X equals negative 1 because it's lining up with our x is equal to h. I will let y'all abbreviate axis of symmetry as A of S, just to shorthand it. But I will need x equals for axis of symmetry, because we are going to get to the point, we do have other equations that are written in the other form, because for these here, the ones we're looking at, it's y equals a times x minus h squared plus k. We do have x equals. We do have parabolas that open to the left or to the right. So especially with axis of symmetry, we've got to distinguish between our y equals and x equals. So axis of symmetry, we do need the x equals or y equals when we get to it. Does that make sense? Okay. G of x equals 2 times x minus 2 squared plus 5. A, h, and k. A would be 2. Interesting. H is, it would indeed be 2, but would the sign be positive or negative? Positive. X minus h. X and minus do line up, yes? So, h is 2. Because there's nothing with the 2, that value of h, that's changing that sign from negative to positive. So it's just positive 2. And k is 5. And luckily, k is exactly what we see. We don't have to flip the sign with k. We can just take it as it is. If it's plus 5, it's positive 5. If it's minus 5, it's negative 5. And that's just based off of our addition properties. Because it's plus k, so if it's positive, we're going to say plus that number. If it's negative, we're just going to say minus. Because we won't say plus negative 5. We'll just say minus 5. Vertex, h comma k would be 2, 5. Axis of symmetry, x equals 2. Questions on this here? So even with this here, we know that the vertex is the point 2, 5. Axis of symmetry, x equals 2 is going to cut it in half. Value of a is positive, so it should open up. Yes? So should look something like this here, yes? Is there a value of x that would make this be 0? Make it cross the x-axis? No, there's no spot it crosses the x-axis, is there? No. So I know just from this understanding of the vertex, the fact that A is positive, it opens up, I have an idea and I have a picture of it. I have an understanding of what the solution should be or what they should look like. Have I actually had to solve anything or do anything to solve it? No, I know already what I should expect. Okay, this is not in your notes. I took this out specifically because it doesn't help. I mean, it is more explanation than anything. Standard form. the form that you're going to see most quadratic equations, ax squared plus bx plus c. This is the standard form for quadratic equations. Now, the way we get to it is explained here, that we're going to have to distribute x minus h out and combine like terms and do some grouping and simplifying. And we get this here, and we can relate a, b, and c to h and k to get it back to vertex form. But the main properties with standard form that we're going to look at to really get the vertex and the axis of symmetry, it is given to us, and it's kind of helpful to know that the vertex is the point negative b over 2a, comma f of negative b over 2a. Axis of symmetry, x is equal to negative b over 2a. Is our vertex and axis of symmetry. The y-intercept is the constant term, our value of c, because again, the y-axis is the point where it crosses the, well, y-axis. It's the y-intercept. And the x value at the y-intercept is 0. So if we plug 0 in for x, the only thing left we have is c. So that's our y-intercept. When a is, the absolute value of a is less than, greater than 1, it's a vertical stretch, so it's going to get narrower. When it's less than 1, it's between 0 and 1, it's a vertical shrink. If a is greater than 0, it opens up. A is less than 0, it opens down. We've talked about this here. Now this x equals negative b over 2a for the axis of symmetry, and negative b over 2a comma f of negative b over 2a seems like there's a lot going on, yes? When we see it and look at this, you're going to see it's not as bad as what you're thinking it's going to be. So when we look at this here, f of x equals 3x squared minus 6x plus 1. ax squared plus bx plus c. A, b, and c are our three terms that these are matching up to. So our value of a in this case would be 3. B is 6, but because we have minus 6x, the negative comes in with the b. And c is 1. Now the values associated with a, b, and c are always going to be a number. We won't have variables. Because if we look in the general form, it's ax squared. So a is the number, x squared is its own term. A is just the number in front of x squared. B is the number in front of x, and c is the number without a variable. If a number is not written in front of x squared or x, it's understood to be 1. If there's not a number in front of x, or if there is no x at all, it's going to be 0. For quadratics, we will always have a value for a, be it 1 or a number greater than 1 or positive or negative. A will not be 0. Because if a is 0, we do not have a quadratic equation. Okay. Vertex. Now the general form is negative b over 2a, comma f of negative b over 2a. I'm drawing arrows here just saying we're going to plug it in once we get it. And we said that the axis of symmetry is x is equal to negative b over 2a. Now the first thing I'm going to find, and we're going to find, is negative b over 2a. Negative b over 2a. Do we know the values of b and a for this here? Yes, b is negative 6. and a is 3. So that negative b over 2a, all we're doing to find that value is we're plugging negative 6 in for b and 3 in for a. Questions on this here? So negative 6 over 2 times 3. Is there a variable in that expression at all? Do we have a variable there? No. It's just straight numbers, yes? Because really we're looking at this thing here. Is there a variable in there? No. And probably the question is, why am I asking about variables there? Because if there's not a variable there, is there anything preventing me from grabbing the calculator and typing that whole thing in? No. And especially on the ACT, they give you an expression that is all numbers, simplify it. Grab that calculator and plug it in. Plug those values in and just stick it straight in the calculator. Say negative 6 over 2 times 3. And it is 1. Because there's nothing wrong with us coming here and looking at this on top. The top of this fraction, negative 6 is going to be positive 6. On bottom, we have 2 times 3, which is 6. And 6 divided by 6 is 1. As we could do it by hand, we can do it in the calculator. Especially on the ACT where time is not on our side, because we're trying to get that done, 60 questions in 60 minutes. It will hopefully be the new format, but it's still a lot of questions and not a lot of time. If we can shorten it or save steps and save time, do that. Okay. Questions on how we found negative b over 2a. We feel good with finding negative b over 2a. Yes? So for the vertex, I know the x value of the vertex. It is 1. Well, the axis of symmetry was x equals negative b over 2a. So that tells us x is equal to 1. So again, what were we trying to find for this here? Vertex and axis of symmetry, yes? Well, out of the two pieces, we have found the axis of symmetry already, yes? We found the whole equation. We don't need to do anything else with that. The vertex, we found half of it. So we've pretty much almost finished this. We found half of the vertex and the axis of symmetry. Now the question is, what is f of negative b over 2a? What is it trying to tell us? Well, f, negative b over 2a, we found out is 1. So really what it's saying is find the value of f of 1. This is just function notation saying, what's the y value when x is 1? Which is really just telling me to take that quadratic equation, 3x squared minus 6x plus 1, take that equation and replace x with 1. Plug the x value back into the function. That's all that's saying. Find negative b over 2a and plug it into the equation. Again, that's all numbers, isn't it? Is negative 2. So we could plug this straight into a calculator. Or we can do it by hand, because 1 squared, 1 times 1 is 1. So we have 3 times 1. Negative 6 times 1 is negative 6. We still have our plus 1. 3 times 1 is 3. Negative 6 plus 1 is negative 5. And 3 minus 5 is negative 2. We got the same value. which means I can come back up here, plug in -2 for the y value of the vertex. So our vertex is the point 1, -2. Axis of symmetry, x equals 1. So really we just use the -b over 2a to find the x value, our h, because we're talking vertex form. -b over 2a to find these two, plug it into the function to find the other value. Questions on this here? I've said it before, I'll say it, I need to redo these note sheets. I need to pull those graphs off of there so that you have a little more room to work. Let's look at this next one here, number 3, x squared plus 2x plus 1. So the general form is still ax squared plus bx plus c. Our value for c in this case is -1. Our value b, the number in front of x, is 2. What is our value of a? 1. It is 1. So we need to find the vertex and the axis of symmetry. Our vertex is our -b over 2a comma f of -b over 2a. And our axis of symmetry is x equals -b over 2a. So the first thing we really need to find the value of is -b over 2a. So the value for b is 2. The value for a is 1. And especially when you type this in, I would make sure to put parentheses around it. Even if b is negative, like the last one, we are going to have that negative parentheses -6. Here 2 is positive, so we have negative parentheses 2 parentheses. And just like with the last one at this point here, we can grab the calculator, plug it in, and let it do it for us. Here on top, -2 is just going to be -2. On bottom, 2 times 1 is 2. And 2 divided by -2 is, or -2 divided by 2 is -1. 2 divided by 2 is 1. Positive divided by, or negative divided by a positive is still negative. So we get -1. So that gives us the x value of the vertex. It also tells us the axis of symmetry is x is equal to -1. Because we can plug that -b over 2a's value, -1, into both its locations. Now the last thing we need to do is take that -1 and plug it back into our equation. Plug it back into the x squared plus 2x minus 1. So that will tell us that we have -1 squared plus 2 times -1 minus 1. Again, at this point here, we can plug that entire thing into the calculator. Let the calculator do that for us. If we do this by hand, -1 squared, -1 times -1 is going to be +1. 2 times -1 is going to be -2 minus 1. Two minus 1 is -1. And -1 minus 1 is -2. Telling us that our vertex is the point -1, -2, and the axis of symmetry is x is equal to -1. questions on this here? Question on anything we've done so far? Not too bad so far. Ready for the other? We're almost waiting for that other shoe to drop. Yes. Let's look at one more. Negative 2x squared minus 8x plus 1. ABC. A in our case is negative 2. B is negative 8. And C is 1. So we do still need to find the vertex and the axis of symmetry. Our vertex is the point negative b over 2a comma f of negative b over 2a. Axis of symmetry, x is equal to negative b over 2a. So again, just like what we did, we need to find negative b over 2a first. So we need to plug b and a into the negative b over 2a. So our value b is negative 8. So we plug it in b's spot on top. The value of a is negative 2, so we plug it in its spot on bottom. So that tells us that we have negative 8 over 2 times negative 2. In the calculator, we hit the fraction and say negative 8 over 2 times negative 2. And they tell us that value is negative 2. So we can plug that value for negative b over 2a in its two spots. We can plug it into the x value of the vertex and the spot where it's equal to on the axis of symmetry. Now the last thing we need to do is to find the y value of the vertex. And to do that, we're going to take that x value, that negative 2, and plug it into x in the equation. So we'd have negative 2 times negative 2 squared minus 8 times negative 2 plus 1. So here, yeah, so 2 times negative 2 on bottom would be 8 on top. Now the positive divided by negative would be negative, yes? 8 divided by 4. You're good. Now at this point here, we can plug that negative 2 in for x, and we will get 9. Notice that the vertex is the point negative 2, 9. The axis of symmetry, x equals negative 2. And we get this here. Because even if we work this other part out by hand, negative 2 squared, negative 2 times negative 2 would give us 4. Negative 8 times negative 2 would be plus 16, plus 1. 2 times negative 2 times 4 would give us negative 8. And 16 plus 1 is 17. And negative 8 plus 17, 17 minus 8 would indeed give us 9. Notice that our vertex is the point negative 2, 9, and the axis of symmetry is x is equal to negative 2.